Most people believe the F-22 Raptor is completely invisible. A fighter jet that cannot be seen, cannot be tracked, and cannot be stopped. It is often described as the ultimate air superiority machine, a ghost in the sky. But that idea is not true. The F-22 is not invisible. And more importantly, modern systems don't even need traditional radar to detect it anymore. So the real question is not whether the F-22 can be seen. The real question is how it is being detected today, and what that means for the future of stealth. Before we go deeper, if you're interested in real explanations of aviation technology, stealth systems, and how modern detection actually works, subscribe to VectorTechExplained, because here we break down complex systems into simple ideas without hype. Now, let's get into it. To understand why the F-22 is not invisible, you need to understand what stealth actually is. Stealth is not invisibility, it is a reduction. The F-22 is designed to reduce its radar cross-section. This means it reflects less radar energy back to the source. From the perspective of a radar system, it looks much smaller than it actually is, but smaller is not zero. Even the most advanced stealth aircraft still reflects energy. It just reflects less of it, and in specific directions. This is achieved through shaping, materials, and coatings. The angles of the aircraft are carefully designed to deflect radar waves away. Special materials absorb part of the signal. Edges, joints, and even panel lines are optimized to minimize reflections. But all of this works best under specific conditions. And that's where the problem begins. Because modern detection systems are no longer simple. In the past, radar systems operated mostly in higher frequencies. These frequencies interact strongly with small shapes and edges, which made stealth shaping highly effective. But today, systems are evolving. Low-frequency radar operates differently. Instead of interacting with small details, it interacts with the overall size of the aircraft. This means even a stealth aircraft like the F-22 can produce a detectable return. Not a clean image, not a precise track, but enough to know something is there. And that is the key difference. Detection does not require perfect visibility. It only requires enough information to begin tracking. Once a system knows where to look, other sensors can take over. And this is where things become even more interesting. Because radar is no longer the only way to detect aircraft. Modern systems rely on multiple sensor types working together. One of the most important of these is infrared detection. Every aircraft generates heat. Engines produce extremely high temperatures. Air friction at high speeds increases surface heat. Exhaust plumes create strong infrared signatures. And unlike radar, heat cannot be hidden by shaping. The F-22 is designed to reduce its infrared signature. It uses special nozzle designs. It manages airflow to reduce temperature peaks. It attempts to mix hot exhaust with cooler air. But it cannot eliminate heat completely, and modern infrared search and track systems are becoming extremely sensitive. They can detect small temperature differences over long distances. They do not emit signals, which means they cannot be easily detected themselves. This makes them passive sensors. And passive sensors are very difficult to counter, because you cannot jam something that is not transmitting. Now combine this with data processing. Modern systems do not rely on a single sensor. They fuse information from multiple sources. Radar provides general awareness. Infrared provides thermal tracking. Electronic intelligence detects emissions. Networked systems share data across platforms. This is called sensor fusion. And it completely changes how detection works. Instead of asking, can radar see the F-22? The real question becomes, can the system detect it in any way? And the answer is yes. Not perfectly, not instantly, but increasingly reliably. And this leads to another important concept. Tracking is different from detection. Detection means you know something is there. Tracking means you can follow it precisely. Stealth is very effective at disrupting tracking. It makes it harder to maintain a lock. It reduces targeting accuracy. But it does not always prevent initial detection. And in modern warfare, even partial detection has value, because it allows systems to react. Fighter aircraft can be vectored toward the area. Air defense systems can be activated, additional sensors can focus on that region. This creates a layered detection environment where multiple systems work together, and this is where the F-22 faces its real challenge. It was designed in an era where reducing radar visibility provided a massive advantage, and it still does. But the environment has changed. Detection is no longer a single interaction between one radar and one aircraft. It is a network. Multiple sensors, multiple frequencies, multiple platforms, all sharing information. This reduces the advantage of any single stealth feature, because even if one system struggles, another may succeed. And once enough data is combined, a clearer picture emerges. This does not mean the F-22 is obsolete. Far from it, it is still one of the most advanced aircraft ever built. It combines stealth, speed, maneuverability, and sensor systems into a single platform. But it is no longer operating in a world where stealth alone guarantees dominance, and this is the key shift. Modern air combat is not about being invisible, it is about managing information, who detects first, who processes faster, who reacts more effectively. Stealth helps delay detection. But delay is not the same as immunity, and this becomes even more important when you consider electronic warfare. Aircraft today are not just physical objects, they are active participants in the electromagnetic environment. They emit signals, they receive signals, they manipulate signals. Electronic warfare systems can jam radar. They can create false targets. They can distort information. This adds another layer to the detection problem, because now sensors must deal not only with weak signals, but also with misleading ones. And this creates a constant battle. Detection versus deception. Signal versus counter-signal. And the winner is not always the one with the lowest visibility, it is the one with the best system, the best integration, the best processing. And this is where the future is heading. Stealth will remain important, but it will not be the only factor. Sensor fusion, electronic warfare, and networked systems will play an equal, if not greater, role. And this brings us back to the original idea. The F-22 is not invisible, it never was. It was designed to be difficult to detect, difficult to track, difficult to target, and it still excels at all three. But modern systems are closing the gap. Slowly, incrementally, but consistently. And this changes how we should think about air combat. It is not a binary system, visible or invisible, detected or undetected. It is a spectrum, a continuous interaction between systems, where advantages shift depending on conditions, technology, and tactics. And in that environment, no aircraft is untouchable, not even the F-22. But that does not make stealth useless. It makes it part of a larger system, a system where success depends on how well different technologies work together. Stealth, sensors, electronic warfare, data processing, all connected, all interacting, all evolving. So the next time you hear someone say the F-22 is invisible, remember this. It is not about disappearing, it is about controlling when and how you are seen. And in modern warfare, that control is everything. If you want more deep explanations like this, where we break down real aviation technology and explain how it actually works, subscribe to VectorTechExplained. And tell me in the comments, what matters more in the future of air combat? Staying invisible or seeing everything first?